Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're here to wire up these output transformers, and I was initially going to do it more of a kind of DIY or, wire by wire, showing you how to wire it up. But when I was recording that video, I screwed up twice wiring it up because this is fairly confusing on wiring up not only the speaker jacks but the phasing of the output tubes and the phase splitters of the transformers. And I was getting too distracted trying to record a video at the same time I was figuring this out. So I decided, since this was this confusing to me and I know what I'm trying to do here, and trying to do it while recording the video got me spun around, I'm going to do a more technical video on installing these transformers or wiring them up. And I'm going to go through the schematic, going to go through the sheet that comes with the transformer, explain what the phasing on a push-pull amplifier is all about, because you've got a phase splitter and there's like what I call a positive and negative phase and a positive and negative phase tubes, and how to figure out which one's which and how to like mark it up and go in here with a voltmeter and make sure that you're hooking up everything correctly and you're not making any mistakes wiring them up. And doing it this way will allow you to use other transformers than just these ISOs. Like if you want to try some Hammond transformers, which I've heard work good on these amps too, or if you want to, use some EdCore, you want to use some Hashimoto, it would apply to any transformer that you're going to put in here, not just this ISO. But I will show you how I wired these up in detail in the next segment as well. So anyway, I just felt, I was making mistakes. I was getting, because one of the transformers is mounted 180 degrees from the other one in the chassis, so the wiring order's backwards, and it can get confusing. And so I want to put this together in a video so that it's not confusing. So anyway, let's get to wiring up these transformers. Okay, to start with, we're going to look at the data sheet that comes with the transformer, and it's going to show you the phasing of the primary versus the secondary. And you can see these two dots here. That's telling you this end of this transformer is in phase with this end of the transformer. So that means P11's in phase with the positive of the output, and P1 is in phase with the negative or the ground of the output. So I'm going to use the term positive phase and negative phase when I'm talking about the primary and the circuit diagram on a push-pull amp, where one output tube is doing the positive phase and another output tube is doing the negative phase. And those output tubes need to be connected to the correct phasing on the primary of the output transformer for everything to work correctly. The other thing to note is that this is oversimplifying this, but the 4 ohm isn't like 4 to 1 and then 6 to 1 and 8 to 1 and 16 to 1 turns ratio. It's more complicated than that. And I'm not going to get into that in this video, but it's not that simple. So you can't simply reverse the output leads on a multi-turn output transformer and get to the same place. So we need to make sure that we get the outputs connected to the right positions on the speaker terminals, and then make sure that we get the power tube phasing correct to each side of the primary on the output transformer. And different transformer companies do things differently. These ISOs have this turret on the bottom of it with pins that are labeled like this, And then, for example, EdCore has wires coming out, and they have the phasing shown by like blue and white blue, and then brown and white brown, to differentiate the positive phase from the negative phase. In this case, the blue wires are the positive phase, and the brown wires are the negative phase. Now, unfortunately, the transformers that come in a R8 have the same color codes for the positive and negative phases. The blue wires are the plates, the yellow wires are the screens. And so it makes it a little more confusing hooking this thing up. But we're going to get through this. So here's the circuit diagram of the modified amp. And there's also a schematic on the internet. It may be on my website too, of the stock one, if you were going to go with that. We are not using this relay anymore. And so we're going to be wiring these directly up to the output transformers without these relay connections. So hopefully that doesn't become confusing. Just know that like these screens are going to be connected directly to the output transformer through this screen stopper, and we've removed this 39K jumper resistor because the only reason it's in there is so the amp doesn't pop when you switch it between triode and ultralinear. So we are hardwiring this thing ultralinear. If you want to try to wire this thing up with the relay board with triode and UL like it was originally, yeah, you can figure that out on your own. I'm not doing that. So anyway, I thought it would be good to simplify looking at this by putting the output transformer in a blown up part of the circuit diagram, looking at the phase splitter, which is the 6 SN7 tubes in the outboard positions, and the corresponding positive phase and negative phase output tubes. So this is the signal coming off the 6SL7 tube, goes to pin 1 first, and this is the positive phase tube. And so we pull the positive phase signal off of pin 2, goes through this 0.22 UF cap, goes over to this power tube. And then the blue lead coming off the plate of this tube is going to come over here and connect to pin 11 on this output transformer, or the positive phase. Then we're going to be taking this wire here that comes off of this 1K screen stopper, which is going to be a yellow wire, and it comes over to pin 10. Okay, got this wire here that is the B plus, connects to pin 9. So then we follow the signal, goes down to pin 4, which is easy to see because it's got this 0.33 UF coupling cap that connects this pin to ground, and pin 5 is then the negative phase signal. So this negative phase signal goes to this 0.22 UF cap, goes to this tube, which is the negative phase tube. So then off this negative phase tube, we've got this blue wire off pin 3 again, comes over here, connects to pin 7 on the output transformer. And then, just like on the other tube, got a yellow wire off of this screen stopper resistor that's going to come up here and connect to pin 8, which is the screen grid tap for the negative phase of the output transformer. And then on this side, you see pin 5 is 0, which is the ground, connects to there. Then you pull the 4 ohm wire off the 4 ohm speaker jack, connect it to pin 4. We're not going to be using the 6 ohm tap. And then the 8 ohm tap connects to pin 2. And that gets the phasing on the secondary aligned with the phasing on the primary. And again, if we were using that EdCore transformer, you would do the blue wire, then the white blue, and then down here you would have the brown and the white brown. And so I hope I'm explaining this in a way that any push-pull output transformer you're going to choose to install, like a Hashimoto or Edcore or Hammond, some people have put Hammond transformers on these things, that you can figure out which output tube is the positive phase and which is the negative phase, and connect the primary up in the correct phase so that everything will work right. The other thing that'll happen if you get the phase inverted, this lead here that goes to our global negative feedback will become positive feedback, and it'll likely start, howling or screaming or making all kinds of weird noises as soon as you turn it on, because you're putting positive feedback in the amplifier instead of negative. And again, you can't just flip the outputs. You would have to flip the primary wiring to correct that problem. So anyway, like I was saying in the intro, I was hoping to make this less technical, but then as I got into it, I decided, I need to do this in a more technical way, so this will apply to any type of output transformer you might want to put in this amp. So let's go look inside the amp and let me show you what this schematic stuff looks like when you're looking inside the amplifier. Okay, so let's take a look inside the amp. First of all, you're going to need like a volt ohm meter. You want to set it to ohms, and then set it where it'll beep, like a continuity tester, so that when you touch the leads, you get that deal going on. The other thing I would get is some kind of a paint marker or some nail polish or something, so we can mark which one of these output tubes is the positive phase on each channel. So first thing you need to do is we're going to look at the phase splitter tube, and we need to find which one of these coupling caps is connected to the positive phase. So come up here, we put it on pin 2, and then it's that one. So that's the positive phase. So then obviously this wire here is going over to this tube, and so this is going to be the positive phase output tube. So just so we can keep track of that, we're going to put a little mark there like that. And then just to double check this is pin 5, and not there. And that's the negative phase, which is this output tube. So we're going to go over to the other channel, same deal. Okay, that's the positive phase, which means that this tube is the positive phase on the other channel. And then just to double check everything, this is pin 5. Nothing. And that's the negative phase output tube. So positive, negative, positive, negative. So now we're going to move the amp up and start looking at wiring the output tubes up to the output transformers. So we've determined that this is the positive phase output tube, and looking at the schematic and the sheet with the output transformer, pins 11 and 10 are the positive phase of the primary. So we're going to come up here, and pin 11 should be connected to the plate of this tube. Pin 10 should be connected to the screen of this output tube. Now you'll notice the way this is wired, pin 6 isn't used in this tube on a KT88 or an EL34. And so we're using it as a tag point for the screen stopper. So we've got our screen stopper resistor that goes from the actual screen, which is pin 4, over to pin 6, and then the ultralinear tap off of the screen tap off the output transformer is connected to pin 6. Just so that's clear. Okay, so we go back and look again at our transformer data sheet, and pin 8 should be the screen tap or the ultralinear tap for the negative phase tube, and then pin 7 should be the plate of the negative phase tube. So that one's wired up correctly. We're going to go over here. Now, remember, this transformer has been spun 180 degrees from this one. See how the speaker terminals are on this side, and then the speaker terminals are on this side? So don't get spun around. I initially wired up these speaker leads wrong because I was looking at this side over here. So on this side it goes negative 4 ohm, 6 ohm, 8 ohm, 16 ohm, and then on this side it goes negative or ground, 4 ohm, 6 ohm, 8 ohm, 16 ohm. So on this side over here, pin 11 is going to be our positive phase output tube plate. And it should be this pin right here. Pin 10 should be the screen tap on the positive phase. And then pin 8 should be the screen of the negative phase output tube. And then pin 7 should be the plate of the negative phase output tube. And there we go. We got it all wired up right. And then you can see in the back of the amp, we got the negative speaker jack that's coming over here connecting to pin 5. We've got the 4 ohm that's connecting to pin 4. And then we have the 8 ohm connecting to pin 2. And then we also have the global negative feedback resistor connected from the 8 ohm to this terminal on this little tag strip that I added, and the yellow wire that goes up to the front end of the amp that is the global negative feedback wire is connected to this terminal here, so we got some place to connect this resistor. And then we did the same thing on this side. The ground is connected to pin 5, the 4 ohms connected to pin 4, and then we have the 8 ohm connected to pin 2 with the resistor coming up here to this tag strip that we added. And I flipped it this way to get this wire away from the choke. And then this yellow wire goes up and is our global negative feedback wire. So that's wiring up the transformer inside an R8. And if you have a different type of output transformer, you can follow the same wiring testing procedure to make sure that you're connecting it all in the right phase. And in another video, I'll go over how to test a transformer that you don't know what the phase is and determine what the output impedance is. And I've done it for a single-ended amp, but we'll go over it with a push-pull transformer in a future video. So hope this helped you figure this out. And at this point, I just need to flip this board over. That's the relay board for the RCA jacks. And we did remove these relay boards that did the triode ultralinear. Again, if you want to keep that functionality, that's going to be fun, because you're going to first have to put some spacers on these and move this board up, which then it's going to get into this cap, And yeah, it's just a lot of trouble. So I would pick one or the other. If you do want to triode strap the amp, you would just leave off these yellow wires and then put a 100 ohm resistor up here between the plate and the screen, and triode strap the tube just right at the tube, and you can just remove these yellow wires from the amp. You can take that resistor out, you can disconnect this wire. None of that needs to be connected. So if you really like the way a triode amp sounds more than a ultralinear, that's what I would do. Like I said, remove this resistor, just get this yellow wire, just get rid of it. You don't need it. You don't need to hook up this screen wire to the transformer. And then just put a 100 ohm resistor between this pin, which is pin 3, and pin 4 on each one of the tubes, and then it's permanently triode strapped. So anyway, this looks like a great place to wrap up this video. Well, here we go. We got it all finished up, and I think it turned out awesome. I did look at the poll, listen to the comments that you guys were making, and I know some of the purists will be like, yeah, you should have left them the stock color and left them mismatched or done something different. I just decided to do a light scuff and put a light coat of that Krylon dark bronze hammer finish paint on the output transformers so they matched the power transformer we painted. And now it looks like it was made this way. I actually think the little bit darker bronze color matches this black anodized finish that the amplifier is a little better anyway. And yeah, it all matches now. That would have drove me crazy. Anyway, all finished up, all wired up, and yeah, I'm ready to power this thing up and run it through the audio analyzer suite and then give this thing a listen and see what it sounds like. I've also got a set of PS Vane 6550 tubes that I want to put in this amp and see what that sounds like. I want to play around with some different 6SL7s. I like the little short bottle RCAs. These aren't the right tubes. I just put them in there so it would have some tubes in the socket. I could go hunt up the right tubes. But yeah, I don't know what those Horizon 6SL7s sound like either. I haven't had a chance to really listen to them. And I wanted to get some good output transformers in this amp before I started really trying to critique these different tubes. So, got that to look forward to, and I just can't imagine this isn't going to be a big improvement. I know the folks over at stereo.net that have put the Hammond transformers in these, just the EI core, budget Hammond things, say it was a huge improvement. And I think a couple of folks have done the Hashimoto potted ones. I think I'm the first one to use these ISO Tango transformers. And somebody did mention the Hashimoto's are black, so you don't have to deal with, painting and mismatches and all that kind of stuff. He said they look fine. And the black Hammonds do as well. I'm not sure how the EI Core Hammonds fit. These look right. They're the right size. They cover up the original holes. And once they're painted all matchy-matchy, I think they look great. And if you did want to go with a lighter color, Krylon does make a kind of a pewter hammer finish, but I think this looks better. So anyway, did have some comments about folks saying, is this worth doing? And yeah, it's hard to say. I mean, are you going to get your money back when you sell the amp? Absolutely not. You're not likely to. I mean, I'm hoping to. If I do sell this, and if I can't, I'll just keep it. Because I wanted it where I would enjoy listening to it. And if somebody else thinks it's worth it, great. If not, like I said, I'll just keep it because I know this is going to be a good sounding amp. The circuit design is fine. There's nothing wrong with the way that is done. And so I think it's worth putting some nice iron on it. And then what are you going to have to pay to get something that sounds better than this? I mean, what is a amplifier that comes with high-end made in Japan iron cost. I don't think you're going to get one for under $5 or $6 grand. And if you can get similar or better sound quality from this amp with a all-in $3,000 investment, I don't think that's a bad thing. Plus, it's just fun DIY and stuff. And if you're not a DIYer, you don't get it. And that's fine too. Anyway, I think this is a good place to wrap up this video. We're going to be doing another one soon on the testing and then a subjective listening. Thanks to all you Patreon supporters and the other folks that support the channel. I really appreciate you keeping this channel going with your support. So, anyway, till the next video, have a nice day.